Welcome back to the Federal Executive Forum on Federal News Network. We're talking about artificial intelligence, machine learning, robotics processing, all kinds of good stuff. I'm going to throw it over to you, Jim. You have a unique perspective at Fortinet, right? You're seeing it across the spectrum. What are you seeing out there? Give us a sense of what's it look like across the community.
Good afternoon, Luke. This has been a great discussion, hearing the breadth of how the federal government is using this. And let me start by building on the comments Erica made. I think there's an increasing understanding and maturation in the federal government of how to do RPA. And part of the challenge now is getting in the direction of intelligent automation. But we all remember the old joke, to err is human, to really screw things up takes a computer. Using RPA to do rote tasks at speed is relatively easy. When you start introducing IA and therefore letting the algorithm have access to different sources of data, to different kinds of connections in your network, it starts pointing you in the direction of cybersecurity. And working with our federal partners, we're seeing an increased interest from them in two big areas of cybersecurity, helping them establish situational awareness, know how to deal with the torrent of data that they're getting from all of the sensors and all of the cybersecurity solutions they have that are reporting into their security operations center. We recently saw a request for information from one federal agency for helping them ingest and make sense of 50 terabytes of data a day, because the reality is the poor analysts are just drowning in data. So that's a problem both for RPA and one that points in the direction of IA, intelligent automation. The second is response. We're seeing an increased interest in security automation, security orchestration and response capabilities, because it's not enough just for them to say, I sense a disturbance in the force, I see what's going on. You have to respond in real time, especially for things like ransomware. So those are the two big things. They're increasingly looking to help make sense in real time of the world from a cybersecurity perspective, and then to respond to those advanced persistent threats, which now you used to be able to say I could respond in minutes. Now with things like ransomware, you need to be able to respond in seconds before it's encrypted your machine and spread elsewhere.
Absolutely. If you're not operating in a machine-to-machine type environment, you've lost that game. Henry, how about over at Cloudera? Somebody was talking, I think it was the folks over at the Jake here, Gregory and crew, about sort of native cloud apps, right? Tell us about what's happening at Cloudera. What do you see out there as far as the community coming together in implementing these capabilities?
Yeah, thank you for having me on here first, and it's a great panel. We've already heard a lot of great content that I really can't just replace what they've said. Everything here has been pretty impressive. Some of the things that you're seeing as we talk to a lot of government clients, I was on a customer site yesterday, is that this is not a model problem. Right. This is not just a data scientist, problem. This is a major full life cycle issue. Right. And one of the things that I think is very interesting in the government space is more recognition of that, less science projects, more pursuit of actually going into production. What does that take? How do you operate across the entire data lifecycle? What does that mean from a security perspective, governance, all of these different areas? How do you, at the same time, understand that full breadth, continue to have innovation? How do you support culture and a workforce that can enable that? And how do you bring in the right technologies at the right time around that front? At Cloudera, we've been doing some really interesting things. One to highlight is some of the work that we recently did at the IRS. We partnered with NVIDIA. So doing data analysis, machine learning at scale, but now also leveraging GPUs. So we've done some pretty significant advancement on fraud detection and helping to increase the speed of model production by, in some cases, almost 30 times what was previously capable. And some of those things allows you to iterate and move more quickly so that you can focus on other issues that it takes to make it to production.
And no question. I mean, the tectonic shift in technology, whether it's GPU or 5G transport or all this IoT collection of data, it's just amazing some of these new use cases that you can born out based on the use of all this technology fused together. Bob, speaking about technology, And global in the title, you're seeing it from a structure standpoint. You're seeing it from a planet Earth standpoint. What are you seeing out there? Tell us, give us some insight as to what you're seeing across the community.
Well, hey, Luke, it's great to be back with you again. And what a fantastic panel and topic discussion thus far. I've really enjoyed it.
Same.
You know, there's so many flavors of AI. And I think the mission applications that are being developed by many of the organizations and agencies that we've heard from is really remarkable. And what we do at ServiceNow is we really look at it from a practical AI approach, right? So when I talk to government agency representatives and executives around the world, there's a common theme that we see coming forward, and it really is informing the strategy that we're using going forward to assist those agencies in delivering the services by enhancing human performance in the processes that they're conducting each day, depending on the persona that they're fulfilling. So when I say that, it's really a digital experience that we're talking about. And we focus on the employee experience and enhancing employee performance by providing contextual information at the appropriate time in a process to assist that person make a better decision with fewer errors faster. We talk about the digital experience of the citizen who is consuming services from government and enhancing that experience and making it a much more personalized experience and much more interactive and easier to use. And then back to Jim's comment, I think Henry mentioned this as well, is the B2B concept of agency to agency interaction in sharing information between agencies is another digital experience that we're focusing on. And we've heard about, you know, RPA and its utilization, where is that appropriate? What we've tried to do, and I believe we're being fairly successful and it's being adopted around the world by government agencies, is provide a native capability fully integrated into a platform that leverages data from systems of record that have already been invested in by government agencies, pulling that data in a normalized format into a data repository through which the supervised machine learning scripts can then provide that contextually at the appropriate point, elevated to where a human has to make a decision or take an action. So we automate all the routine and repetitive processes that happen each day. And those activities are fully vetted by humans before it's turned over to the RPA bots to conduct those repetitive processes. That reduces errors, it increases the speed, all the great things that we get from an RPA-like capability. But then we reserve that human decision-making where we have a policy or a legislation that says that a human has to make that decision. Mm-hmm. And Luke, it's a lot like we've always talked about. There are inherently governmental responsibilities where a government executive has to make that decision. It can't be a contractor, can't be a machine. Now we find there are inherently human activities where we've got to reserve that activity to a human decision. But we can enhance that decision by providing that contextual information that increases the performance of the employee, enhances the experience of the citizen or the other agencies that's consuming that. We do that in a fully integrated platform that's supported with multiple releases. So now the agency doesn't have to try to figure out what technology is going to work, how do I integrate that, and how do I care and feed for it. They can focus on mission applications and the really cool AI stuff, like we heard that the Navy is doing with robotic in-flight refueling, which I think is super cool.
Yeah, you know, and fulfilling that promise to the customer, right? Whether that's the warfighter, the citizen, the business owner, the farmer, et cetera. Super important that we stay focused on that. Well, we're going to roll over and start talking about a specific program. Sanjay, I'm going to go over to you at Department of Labor. Give us an example of a specific program that you'd like to highlight that you all are focusing your attention on right now.
Great, thanks, Luke. So, you know, we're doing we're from a foundational standpoint, we're doing a lot of really interesting things. Some of it's more on the road part. So recently we've been piloting a lot of form recognizer AI services at DOL to help agencies to process worker eligibility forms faster and automate the manual processes for, you know, faster, quicker approach to customer service that usually took a lot of human hours. So we're looking at that as a service that we can put out there. I think at a bit more of a complex level, our office has been partnering with DOL's Veterans and Employment Training Services to pilot how AI tools can be used to more successfully transition veterans or transitioning service members, military spouses, and other active duty members to civilian employment by trying to match their skills with employer needs and education. And the current experience we've seen right now has been that transitioning service members have to navigate a sea of support and information systems that can lead to a number of challenges in finding the right opportunities. And so the pilot we're pulling together is leveraging AI to pull information from a number of sources and then adding intelligence on top of it so that vets and their spouses can be recommended with options for what might be better ways to re-enter the workforce. What's cool about this piece here is not just trying to make it easier for a really important group, but also they're looking at how you evaluate and ensure the implementation is done in a responsible and equitable way, which is another really important element when you're looking at veterans. So as we're starting to look at some of these more complex cases and piloting it out, we're eager to see what the possibilities are, not only with helping to drive that mission support, but then also how do we look at responsible AI and ensuring that it's helping to make the right decisions in an equitable way.
What a great use case, and what interesting nexus from labor over to the veterans community. I think that's fantastic. Jim, how about over at Fortinet? Give us an example of one program you'd like to highlight.
So Luke, we've been using AI in production in cybersecurity for over 10 years. And in that 10 years, we've discovered that the algorithms become more refined. They give you better predictive power. So we're getting better at that end of it. But equally important, we've discovered that not all of the data that you bring in is equally relevant. Of the trillions of records we've seen, it turns out that a handful, between 5 and 20 million pieces of security data, is enough to give you a good starting set to say, I know what's bad, I know what's good, and I know what common false positive false alarms look like. And the power of this, Luke, is it's now allowed us to take a subset of that more precise set of algorithms and this small set of data and decouple it from the data center. Not something we need the multi-billion node neural network, but something that we can say, look, here's a hardware or a software version that you can deploy in an agency as a virtual security analyst that can help you identify, triage, and even to Bob's point, be pre-programmed to say, if you see this, alert a human. If you see that, quarantine and alert a human. We've delivered that kind of capability because we're at that point in the maturity curve of developing this technology.
Fantastic. And I love the reference to a handful, and then you say 5 to 20 million, of course, in the context of trillions of records. Speaking of trillions of records, I'm going to go up to you, Greg. You talked about an absolute superstructure that you're laying down up there at the Jake. Give us an example, one program you'd like to highlight.
Sure. And before I get into the one program, let me just emphasize that artificial intelligence is a general purpose technology. So imagine it was the year 1990, and you asked, what is the DoD doing with computers? Well, a lot, right? And a lot of different types of things. And we're at a similar stage in AI where it is a technology that has application, not just to one area, but to many, many, many areas. And the Jake is involved in AI-enabled capabilities across cybersecurity, across military logistics, across command and control systems, and the stuff at the sort of pointy tip of the spear. So artificial intelligence is relevant and capable to all of those things. I'll highlight just one program that we've been up to here at the Jake in partnership with United States Cyber Command and others, which is artificial intelligence for cyber intrusion detection and for network analysis and anomaly detection. And the basics here are that the amount of cyber data flowing through a network at any given moment is extraordinary, right? All of the activity of all the transfers of that data following somewhat regular patterns, but also the occasional blip that looks different from different other types of things. And in traditional software, you would create a rule that says, anytime something comes in, looking like this, flag it for human review. And that would be a traditional software approach. But with machine learning and artificial intelligence, you don't necessarily have to tell the cyber system, this is what I'm specifically looking for, execute this rule in order to find those sorts of things. You can just give it examples of anomalies. And it will come up with the rules by itself for the best way to detect those. That's in a supervised machine learning environment. There's also unsupervised machine learning, where it can just say, I have analyzed all of your data, and here are the parts of your cyber network data that look the least like traditional traffic patterns or traditional user activities. And that really helps accelerate the speed and efficacy of our cyber warfighters and our cyber defenders, because they don't have to actually go through and manually review all of this stuff. The artificial intelligence systems can identify and prioritize what they should be working on in a given day by saying, this is the stuff that looks the most interesting, start here. And we can really use AI in cooperation with humans to accelerate their productivity or to automate routine tasks that are not a great use of their time.
A great use case there, and laid it out perfectly about just sort of taking that rote activity off the table, allowing them to focus on this higher order parts of the value chain. Henry, how about over at Cloudera? Give us a specific example that you'd like to highlight.
Well, it's unfortunate that you made me follow the Jake, but no, I think that was a really fantastic, and I love what you said there because it's applicable to so many different use cases, and it's not one where you're talking about just in a corner. It's applicable across the public sector space, specifically in the DoD. Some of the work that Cloudera is doing, we're working on predictive maintenance use cases using machine learning, which has been really fantastic for keeping airframes in the air. Right, we when you look at what was being done from a legacy perspective, you had some private on the ground doing a handwritten checklist of, did you do this? Yes, no, right. And what ended up happening is the pilot would say, no, right. And then you'd have a maintenance problem in a month and it'd be down for several weeks. Right. But now what we're actually collecting data off of the airframe as these things are happening and realizing that, hey, given all the models and things that we know about this airframe, this part is going to go bad, and then that initiates an ordering of that part, delivery of that part. So when it comes time for maintenance, you're not having a catastrophic failure involving, at worst, a safety issue or your airframe being down for several weeks. You're down for a very short maintenance of time, and your materials are already there. And it's a fun use of machine learning that has actually greatly improved some of the effectiveness of our warfighters. And then also with the DoD, doing things like not just having to do the traditional machine learning in a data center, but also bringing that out to the edge in real time. So from a healthcare environment, working with military members to say, if you're in the hospital and you have a set of you have this marker and this marker and this marker, that means that you're having a heart event, and we actually need to get a doctor involved and have intervene in that process immediately. So there's some really interesting use cases that Cloudera is working on with the DoD, and like I said, Greg, I think you hit the nail on the head. This is applicable everywhere.
Yeah, as we talked about computers in the 90s, AI in the 2020s, great context there. All right, we're going to take another short break and we'll be right back. You're listening to the Federal Executive Forum on Federal News Network.